Power sources usually do not provide energy in a straightforward form suitable for IoT devices. AC sources require lowering of the voltage conversion from AC to DC and stabilization, as needed by MCU, which is fragile for voltage variations. Typical conversion from the grid to IoT is presented in the diagram. It includes AC to AC conversion to lower high voltage, AC to DC conversion, filtering, and voltage stabilization, which is usually a step down. On the other hand, battery-powered devices use DC to DC conversion and following voltage stabilization because battery voltage rarely fits MCU requirements and changes during the charge and discharge process. AC to AC conversion historically used heavy transformers with fixed conversion rates and usually a steel core. Modern converters use a switching mode power supply that contains only a tiny coil. These converters are technically much more advanced, but they are also lightweight, accept a wide range of input AC voltages, and are cheaper. Nowadays, switching mode power supply contains all components in the single enclosure, providing a stabilized voltage at their output. Proper filtering of the current interferences is essential to ensure stable MCU operation. Even when using good quality power sources, nearby communication wires, power wires, and electromagnetic fields generated by actuators can cause severe voltage interference to rise and drop. For this reason, the use of capacitors is essential. A rule of thumb is to add a large capacity, example 1000 microfarad capacitor, on the power bus and 100 nanofarad capacitors close to the IoT device's MCU and other sensitive components. DC to DC conversion is needed whenever the source voltage is unsuitable for the IoT device. It is also needed in batteries as a second stage after AC-DC conversion. DC-DC converters include voltage stabilization. Modern DC to DC converters are implemented with fixed output voltage or regulated to decrease, so step down, or increase, so-called step up, the voltage. Some circuits can implement both, step up, down, where voltage is controlled with a regulator, usually a potentiometer. There are two general types of DC-DC voltage converters: linear and switching. Linear converters are stable, but their maximum current is limited, as they tend to heat during work. Switching DC-DC converters are high complexity and require good build quality, but they have much better conversion efficiency, reaching over 90%.